All right, welcome everybody. I'm just going to go through this slideshow and talk to you guys as I would if we were in class together. So I'm going to have this slideshow available for download, but just know that some of the context of the slides is available through audio and closed captioning in this video. So please listen to me talking as I go through, and it'll make a little bit more sense. So we've gotten to know a little bit about photography through our reading and some of the videos and of course our cameras that we now have set up. And when we think about what photography is, I really feel like we take it for granted a lot of the time. And when we look at an image like this, it's a fun image to look at, and perhaps you think it's fake. But I want you to, for a second, consider the simple question, what is photography, really? The word photography is based in Latin roots, and it makes sense when you break it down. And it's recording light or writing with light. So photography is literally light writing, recording light and time. And that's a really wonderful idea, capturing light beams, right, that are bouncing off of everything into our eyes, and we can record that. An image like this is not a fake image. It's actually an image that is recorded over a long period of time, right, in which all of the lights in the picture were allowed to go off while the duration of the exposure was happening in the camera. And so photography is literally recording light. And of course, we already know that we do that with a camera, right? Which is really simple concept, just letting light come into a dark space, like the inside of our eyeballs or inside of a dark box. Any little hole that allows light to come in, we can record that light and capture it with a film or a sensor. And in history, we would do that with film processes, right? Surfaces that were coated with light-sensitive materials like in film. And now we have digital sensors that convert that information into ones and zeros, just like everything else we see on the internet or on our computers. And we call that process of recording light an exposure, right? Just like getting a sunburn, if you expose something that's light sensitive to light, you can make a change to that thing, to that surface. So if you think of your skin, for example, when you get a sunburn, right, it's because your skin, a light sensitive surface, was exposed to sunlight and therefore changed, right? The pigment and the melanin in your skin reacted to the sunlight. And in the same way, a film that's sensitive to light may be coated with silver, or a digital sensor that can pick up the energy from light converts it into ones and zeros, right? That is an exposure, letting light into your camera to hit a sensor or film. That's exposure. So when we say exposure in photography, we're referring to the process of letting light fall onto a photosensitive surface and render information. So when we think about that, there's two things that are really simple to consider within exposure, right? How much light there is, the intensity of light, and the time that we allow that intense or not so intense light to fall onto that surface, right? If it's a cloudy day, maybe not as much light hits your skin, but maybe you stay out longer. Or if it's a really bright sunny day, maybe you're only out for a little while, but you're getting a lot of light exposure, right? So in exposure, really there's two important things to consider: intensity, or the amount of light, and time. And as you are reading and learning about how we control those two things in photography, you can think of intensity as how much light is entering the camera, maybe through an aperture, and how much time passes, or how much time is allowing light to enter into the camera, right? And we do that, we control that with shutter speed. And if we think about that in terms of the functions of a camera, we can look at a diagram like this, which is a diagram of a basic SLR camera or a DSLR camera, either one. And we can understand how that process is functionally happening, right? To the very right-hand side of the screen here, we have the light path, and that light is entering through a lens, and that lens helps us focus the light. And then it passes through an opening, the aperture. You can change that aperture size. You can make it a small hole or a large hole, therefore affecting how much light enters the camera. After it passes through there, of course, it bounces over a bunch of mirrors so that you can see it in your viewfinder. But once you click the shutter release, that mirror flips out of the way and a shutter door opens, allowing the light to pass through the hole through the aperture and back through the open door onto your sensor or film. And that shutter, however long it's open before it closes again, that's your shutter speed, right? So you're letting light come into through an opening, and you're letting it come through a door for a certain amount of time before the door closes again. And in the very back of your camera, you have a sensor of some kind that records that light information, right? And that's what's happening every time you click a camera shutter, whether it's in your phone, whether it's in your DSLR, doesn't matter, right? You're letting light into a system for a certain amount of time. And the first way that we're going to describe that is in terms of aperture, right? Aperture is the size of that hole, right? In photography, we measure apertures through sort of a complicated ratio measurement system of the distance from the front of the camera to the back versus the size of the hole. But all that you really need to know is that we measure apertures in f-stops. And those f-stops are represented by numbers, right? And when you start to learn about how to set your f-stops or the size of your aperture hole in your camera, you must remember that the smaller the number, the larger the hole. So an f-stop of something like 1.8, or maybe in your lenses you have something like f4, these are rather large holes that let in lots of light. It's like when your pupils dilate at nighttime, right? If you've ever seen a cat at night with big pupils, it's letting in a lot of light. Now, on the other side of the spectrum, you have numbers like f11 or f16 or f22. These higher numbers correspond with smaller holes, right? Letting in less light. Okay, so all that you really need to remember is that when it comes to f-stops, right, the smaller the number, the larger the aperture opening. The higher the number, the smaller the aperture opening, right? Now there's another effect that those different size holes produce, right? And it's called depth of field, and we're going to talk about that more later. But just know that if you use a really large aperture opening, it really isolates how much focus you achieve in your picture. In this picture by Elliott Erwitt titled The Kiss, he used a very large aperture opening, something like 2.8, letting in lots of light. But one of the effects of that is that you only get a certain area of focus while everything in the background becomes blurred, right? This is referred to as a shallow depth of field. And if you use a really small aperture, right, like f22, then all of this would have been in focus, achieving what is referred to as a deep depth of field. And we'll talk more about that later. So there's multiple things to consider. The next part of exposure we're going to talk about is shutter speed. And shutter speed, again, is the duration of time that we're letting light into the camera, right? We talked about aperture, the size of the door. And shutter speed you can think of as the time in which we allow the door to be open, right? Exposure time. And when we talk about exposure in photography, we measure that time in fractions of seconds usually, right? Light moves really fast, and we all know that. The speed of light is really quick. And so time is very important in exposure because if we let too much light in or not enough light in, it results in too bright or too dark an image. So we really have to balance how much light and how much time we let light enter our cameras. So an exposure time, or our shutter speed, is usually referred to in fractions of seconds. Okay? And we refer to that in terms of these fractional representations of numbers. So when you're setting these shutter speed settings on your camera, something that looks like this with a 1 followed by a couple of apostrophes, that's a really, really long shutter speed. That's 1 whole second. Now, in normal day-to-day life, 1 second is not very long. But in photography, a lot can happen in 1 second. Think of how fast you can move your hand across your face in 1 second. That's a lot of blur, right? You can't hand-hold a photograph at 1 second and get a completely sharp image. And as we decrease the amount of time, you'll see that it sort of decreases almost by half every time, right? We go from 1/2 of a second to 1/4 of a second or 1/4 of a second. Then we divide that into 1/8 of a second. and then a 15th, and then 1/30th of a second. This is where we get to the type of shutter speeds in which are fast enough to where we can handhold our cameras. So if you're setting shutter speeds and you're getting blurry photographs all the time, perhaps it's because your shutter speed is too slow and your hands are shaking. If you're like me, I need a lot of coffee and I shake a lot. So 1/30th of a second is about as slow or as fast as I can shoot my camera holding it in my hands. And any slower than that, and I need a tripod. Now, of course, we can shoot a lot faster than that. 1/60th of a second, 1/125th, 1/250th, 1/500th of a second. Now we've divided 1 second into 500 pieces, right? At that point, we can start to freeze even the fastest motions, someone jumping in the air or running really fast. And shutter speeds get even faster. My camera goes all the way up to 1/4000th of a second. I could stop a helicopter rotor at that point. But you have to remember, the faster you go, the less light that's coming into your camera. Only so much light can come in when you open the door for 1/4000th of a second. So remember, it's a balancing act between the size of the hole, the f-stop, and the amount of time that you're letting light in, the shutter speed. This is an example of a really fast shutter speed, right? Many hundredths of a second, something that's faster than all of our normal cameras. Here we have a bullet being fired through an apple, right? The shutter speed had to be extremely fast to capture that bullet in the air right after it went through this apple, right? An extremely fast shutter speed. And this is a film photograph, by the way. This is not Photoshop magic. This is before Photoshop. On the other side of the spectrum, when we open up the shutter speed for a really long time, right? When we let the door stay open and we let light pour into our camera over the course of a very long time, weird things can happen, right? Because things move, right? And here we can see this is a launching of a Falcon 9 rocket off Cape Canaveral. And at the bottom here, we can see this bright light from when the rocket first started launching. But the exposure allowed the shutter to be open so long that we tracked that rocket's course into the upper atmosphere as it went up into space. We can even see the different stages of the rocket and it being affected by the rotation of the Earth here, making the arc, right? And you can see that things that stood still for that maybe minute or two are rather sharp, right? The horizon didn't move, so it's rather sharp down here. But anything that moved, like this rocket or the clouds or maybe the heads of these children, anything that moved during that long exposure becomes blurred. Right? This is how you get those photographs of streaks of car lights on a street. The shutter stayed open so long that the car moved from one point to another while the shutter was open. The last component of exposure that we're going to talk about today is ISO. And ISO, it simply stands for International Standard of Organization, and this is a measurement system. So it's a way of categorizing how sensitive or not sensitive a surface is. And so when we talk about ISO, we're referring to how sensitive or not sensitive our camera sensor is to light. So a low ISO number, like maybe 100 or 200, is not that sensitive to light. Whereas something like 1000 or 6400 might be really sensitive to light. Okay? Now, the higher your ISO is, right, the higher sensitivity you have to light. So that means that you can open your camera's shutter door for a less amount of time to get a good amount of light because you're so sensitive to light at that point. And like our apertures and shutter speeds, there are scales. So in ISO, we go from things like 50 or 125 all the way up to things like 3200 or 6400. Okay? Down on the left-hand side here, these lower numbers mean less sensitivity. And these higher numbers mean more light sensitivity. So when you're shooting in darker situations, these higher ISO numbers mean that you can use a fast shutter speed or a relatively small aperture. Because you're so sensitive to light, it doesn't take a whole lot. But there is a catch. The higher your ISO, the more grain or digital noise you get, right? That all that sensitivity to light means that you get all these kind of grainy dots in your image. So you want to be careful not to increase your ISO too high unless absolutely necessary. And we're going to go into more detail about this later. It'll make more sense. But generally, when I'm shooting, I like to operate somewhere between maybe 200 and 800. That's a good safe range, right? 400 or 500 being kind of in the middle. And I'm going to ask you guys to operate in ISO 400 to 800 most of the time, just for the learning, all right? Here's an example, though, of what the differences in ISO would look like. On this side, ISO 100 is not as sensitive to light, but if we let enough light come into our cameras, we can get a nice clean image of this building at sunset. And we can see that the color is relatively smooth and the detail is nice. Now, this higher ISO image of the same scene maybe was shot with a faster shutter speed or a smaller aperture. Because we used a higher ISO that's more sensitive to light, it maybe required less time or less light to get the same brightness results. But the catch is that now we have all this noise, all this grainy noise. It's a bummer. So that's one drawback to using really high ISOs, so keep that in mind. Now, what you'll read about in Henry Hornstein's book, and what a lot of people discuss when they're talking about manual exposure, is balancing your exposure triangle. And the idea of a triangle is rather arbitrary. It doesn't really matter. What it really is for is just a way to simply visualize the three main components of exposure. On one side, you have shutter speed. On the other side, you have aperture. And on the bottom here, you have ISO, or film sensitivity, right? And you can see on one end, your shutter speed is really slow, letting in a lot of light. And on the other side, your faster shutter speeds, like 1/1000th of a second up here, let in not very much light at all, right? Because the door is only open for a short amount of time. But on the other side, we have apertures to balance that with, right? We have a large opening at something like f1.4 or f4, right? These larger holes are achieved with a lower f-stop number. But as we go down the f-stops, right, something like f22 or 32, that's an extremely small hole, letting in little amounts of light, right? So we might use those to balance this out. And then, of course, on the bottom, we can't forget how sensitive we are to light. Our ISO sensitivity will affect how we use these other two options. If we're using a really high ISO that's really sensitive, then maybe we can shoot really fast because we don't need that much time to get enough light for a good picture if we're really light sensitive, right? Or maybe we want to get a lot in focus, so we use a small f-stop hole because we want that beautiful depth of field that I was discussing, right? So then we use something like f22. Well, then we need to let in a lot of light with our shutter speed because we're not letting a lot of light in here through this tiny hole. Or maybe we up our ISO so that we can use that tiny hole to become more sensitive. And it can go the other way too. So the exposure triangle is just a way of thinking visually about the three components of exposure. And we're going to go into detail about these three things later on. And as you apply them in your cameras, it will make sense to you with the help of a light meter. Now, if you guys watch my video that I have up about my light meter in my camera, it will look something like this, and I discuss all of this in detail. But when you guys are looking through your viewfinders on your camera, you will see something like this. When you push your shutter button down halfway, you'll see a light meter come up, right? And aside from things like your battery power or how many shots you have left on your camera, the three main things that you really want to focus on are, of course, your shutter speed setting, which is represented here, your aperture setting, which is represented here, and then your ISO setting, which is over here. But in between them, there is this little graph of lines, and this is your light meter, right? On this side of your light meter, you have a -2 or a -1, and on the other side, you have a +1 and a +2. And then in the middle, you have this little mark, right? If you can get your light meter to zero out in between, that means that your exposure is going to be proper, that it'll be well lit most of the time, right? And if you have all these lines lit up on one side or the other side, it might mean that it's too dark or too light, or that your settings are not letting enough light in, or maybe they're letting in too much, right? So you use this part right here to know whether you're underexposed or you're overexposed. The -2 and -1 side is underexposed, not enough light, and the +1 and +2 is too much light. And of course, these little dots will light up on either side depending on how your settings are. So you just have to remember that when you're looking at your light meter. The +1, +2, too bright. The -1, -2, too dark. And you want to try to get your exposure meter to read somewhere close to 0 to get a well-lit image. We refer to this as zeroing out your light meter or balancing your light meter. So here you can see a correct exposure in the scene that would be maybe kind of a cloudy day would be with an ISO of 200. We have set 1/125th of a second at f16, right? So your aperture is at f16, it's kind of a medium-sized hole, 1/125th of a second, pretty fast. And that exposure value with those three numbers give us a good amount of light in our camera, so our meters zero out. Now, in that same scene, if I decide I'm going to open up my f-stop, make the hole bigger, and change my 16 to 11, making a larger hole, now I'm letting in one stop too much light. And we refer to these increments as stops in photography. And of course we have half stops and quarter stops, but we're talking about values of exposure, we usually say stops. Right? It's a nice way to measure the amount of light coming into your camera. So here we can see from f16 to f11, the hole has gotten bigger, and so now we're overexposed. If I was to increase my f-stop number and make that hole smaller, like f22, now I'm underexposed, right? I'm in the minus. Now you can recognize here that my ISO and my shutter speed stayed the same, and the only thing that changed here was my f-stop, right? I made a good exposure reading here, and then I let in too much light by opening the hole, and then I let in too little light by closing down the hole too much. Now the same thing would happen if you changed your shutter speed, closing or opening the door for too little or too long, or making your camera too sensitive or not sensitive enough to light would cause the same thing to happen. So it's a delicate balancing act that can be kind of confusing at first, but you'll get used to it. Now there's a quick little way during regular lighting conditions outside to get an almost good exposure every time. It's called the sunny day rule. And the easiest way to remember this is to first make sure that you're shooting on a well-lit day, and second, to set your ISO and your shutter speed to be the same number. So if you have an ISO of 400, just set your shutter speed to 1/400 or 1/500th of a second. Get close, all right? See, 400, 500, not too far off. And you actually do have a 400th of a second shutter speed. It's actually a quarter stop. It's in between, but your digital cameras have them. Right, so do that first. If you're out on a sunny day, choose an ISO, maybe like 400 or 200, the lower the better, right, less grain. And then make your shutter speed the same number, 1/500th of a second at, an ISO of 400 or 500 like this. And then you always set your aperture to f16. And if you're out on a sunny day, this won't fail, right? Set your aperture to f16 and make your ISO and your shutter speed numbers the same, and you're gonna have a close exposure. And of course, if it's a little too dark or a little too light, you can adjust one of these a little bit and make it more perfect, right? But this is a good way to get started outside, zeroing out your meter, so that you're not just randomly picking these and getting frustrated trying to balance your light meter. So maybe go outside on a sunny day and start here and think about how much light you're letting in with your different settings and adjust accordingly. Now, different combinations can yield the same result, right? We call this equivalent exposures, right? So if we have a situation where we have maybe like a 400 ISO set, and we have maybe a 1/125th of a second shutter speed, and our light meter tells us that at those settings, f32 is a good exposure. But if I need to maybe increase my shutter speed a little bit to 1/500th of a second, right, I'm letting in less light now. So my meter is going to tell me that I'm underexposed because I've sped up my shutter speed, letting in less light. So a way to balance that would be to open up my aperture a little bit, to let in more light through the hole. Because I've sped up my shutter speed, maybe in order to capture movement, for example, but now my image is too dark, I can always open up my aperture a little bit, letting in more light to balance it out. Or I could also increase my ISO a little bit to make it more sensitive, to compensate for that darkness that I achieved by making a faster shutter speed. So you really have to decide what's important to you. Do you want to use a fast shutter speed to capture movement? Or can you get away with using a slower shutter speed? And then in that case, you could choose what kind of f-stop you want to use, right? Maybe if you wanted to get a shallow depth of field and focus on one little detail in an image, you could use a really wide open aperture like f2.8, but then you might have to balance your exposure by using a faster shutter speed to compensate for all the light coming in through that big hole. So again, it's a balancing act. But what that means is that different setting combinations can yield the same ultimate exposure, right? It's all about the amount of light at the end. So if you see here, because we go one direction on one setting, we have to go the other direction on the other setting in order to compensate or balance our meters. And this is called equivalent exposure setting. And you're going to practice this later on in the module. So if it's not making sense now, continue reading and do the prompt exercise that I have in the later on in the module with your cameras on manual, and you'll get a good grip on it. And it's always good to test yourself, right? If maybe you've set a good exposure, like here, maybe we have a scene in which we metered, and at f22 at 400 ISO, our meter says we have to shoot at 1/8 of a second. But now, 1/8 of a second is really slow. I can't handhold that. I need to shoot faster to stop motion. So I speed up my shutter 1 stop, 2 stop, 3 stop, 4 stop, 5 stops, right? So now I'm all the way up at 1/250th of a second. But I'm letting in a lot less light, right? 5 times less light. So what am I going to do in order to balance it out? Well, I'm going to need more light, right? Because I've just decreased the amount of light in order to stop and freeze motion with a fast shutter speed, but now I'm not letting a lot of light in. So what I have to do is I need to open up my f-stop. 1, 2, 3, 4, 5 stops. And now that 5 stop difference is going to equal a good exposure, right? And you always need to be looking at your meter to try to zero it out, because ultimately none of this matters if you're not getting a good, well-lit exposure. So always be checking your light meters, trying to get as close to zero as you can, and of course checking your LCD screens to get a good image. Okay? Again, if this isn't making sense yet, it certainly will. You have to go practice your equivalent exposures and your meter settings by looking through your camera's viewfinder and adjusting your shutter speed and your f-stops accordingly in real life, and try to do it in well-lit scenes in the beginning. Okay? That's it for now, and please continue through the modules, and there'll be lots of different kinds of media that reiterate these ideas. Make sure you get your readings done, and of course do the exercises and get some images shot so that we can import them into Lightroom and get editing. Okay, thanks guys.